In this video, I want to review and reinforce the skills that are needed in order to use the indirect method of using truth tables. And as we saw, this method hinges on our ability to work backwards from the truth value of a main operator of a compound statement to the truth values of its simple components. So for example, if I am told that the claim it is both the case that A and B is true, that because of what I know about the truth functional nature of the conjunctive claim, I can then know that A and B are true. Similarly, if I know that if A, then B is false, because there's only one possible world in which a material conditional claim is false, and it's one where the antecedent is true and the consequent is false, I can then plug those in. However, if I am told, for example, it is both the case that A and B is false, I am not, the process isn't quite as simple because there are actually three possible ways in which that might be the case. It could be if the one conjunct is true and the other is false, vice versa, or if they are both false. But nevertheless, I can create a truth table beginning with knowledge that the conjunctive claim as a whole is false. I can work backwards and reconstruct the three possibilities for the possible truth values. Same if instead of if A then B being false, if the claim was if A then B is true, there are similarly three possible worlds in which that is possible. One in which both the antecedent and the consequent are false, one in which the antecedent is false but the consequent is true, and one in which both the antecedent and the consequent are true. So this is the basic kind of insight that underwrites and makes possible the use of indirect truth tables. Because when we do an indirect truth table, as we explained or saw in class, we start on the assumption that our argument is invalid, which means that we assign a truth value of true to the main operators of all premises and a truth value of false to the main operator at the conclusion. So here's an argument. Premise 1 asserts it is if not A, then either B or C. Premise 2 asserts not B, and the conclusion is if C, then A. Now, the way that we go about doing an indirect truth table is we assume that the argument is invalid, which means that we assign a truth value of true to each premise and a truth value of false to the conclusion. As we saw on the previous page, if I know that the conditional claim, if C then A is false, then I know that C is true and A is false. So I'm going to carry those truth values over to the other instantiations of the atomic proposition and continue to work backwards. So if I know that A is false, I know that not A is true. If I know that not B is true, then I know that B is false. So I'm going to plug that in there. B is false and C is true, so B or C is true. And I've now worked backwards and assigned truth values without running into any errors. And if I do not run into an error, then I have proven that the argument is invalid. Because again, we started by assuming that the argument was invalid, and by working backwards, by working backwards, we were able to consistently create a line without running into a logical contradiction. Let's consider another example. So now let's suppose the argument is if A, then B or C. If B, then D. Third premise is simply the assertion that A, and the conclusion is if not C, then D. This is my main operator for the first premise. This is my main operator for the second. The third premise is simply an atomic proposition, and the conclusion is a conditional claim. Okay, so once again, I know that since this is false, it would have to be true and false. If not C is true, then C is false. So I carry that over. I carry D, the falsehood of D, over. Let's see here. Now, what else can I know? So I know that the conditional claim, if B, then D is true, and yet D is false. That means that B cannot be true, because that would be a contradiction. So B has to be false. If B is false there, then the disjunctive claim is false, and we've already determined that A is true. So now, in this case, I have reached a contradiction because I've had to assert that if A, then either B or C is true, yet by performing logical steps, working backwards, I've determined that A is true and B or C is false. So I have a true antecedent and a false consequent, and yet I'm committed to the claim that this is true. So this is a contradiction. And so what I've proven is that on the assumption that the argument is invalid, I reach a logical contradiction, so the argument is valid. Now, so far in these examples and in most of the examples we talked about in class, we've been able to work on just one line, but that's not always going to be the case. Sometimes sometimes a single row of truth values isn't going to be sufficient to prove that an argument is valid. And here's an example of a case like that. So my first premise asserts if not A, then B. My second premise asserts if B, then A. My third premise asserts if A, then not B. And my conclusion is that it is both the case that A and not B. So I assign my truth values on the assumption that it is invalid. And now I see what we can do. Now, since a conditional statement can be true in three ways, and a conjunctive statement can be false in any one of three ways, merely assigning truth to the premises and falsity to the conclusion of this argument is not going to be sufficient to obtain the truth values for any of the component statements. When you're faced with a situation like this, the best way to proceed is to either to list all of the possible ways that one of the premises can be true, or all of the possible ways that the conclusion can be false, and to proceed from there. For this demonstration, we're going to focus on the conclusion. Since the conclusion is a false conjunctive statement, the first conjunct can be true and the other false. The first one could be false, and the other one true, or they could both be false. I'm going to duplicate my initial assignments over there. And now I'm going to just begin carrying out, filling in the rest based on these initial starting points. So on this line, B is true. Now, and A is true, sorry. Now let's see if I have a contradiction anywhere. So this conditional claim is true, and that's fine. The antecedent is false, and the consequent is true. This conditional claim is true, but that's fine because the antecedent is true and the consequent is true. This conditional claim is true, but notice the antecedent is true and the consequent is false. So I reached a contradiction there. Now, since I've reached a contradiction there, all I've shown is that on this assumption, or in this logically possible world, where A is true and B is true, I can't sustain the assumption that the argument is invalid. But I'm not permitted to conclude that it's invalid yet, because I have to see whether it would, any of the remaining two possibilities would yield a consistent line. So now I have to go down to my second line. Here, B is false, and A is false. Let's see if I've run into a contradiction here. So here, the conditional claim is said to be true. The antecedent is true, but the consequent is false. So I've reached a contradiction on that line. So again, I'm not done. I have to go down to my third line. Now, if I had if I had obtained a consistent line on line 1, I would be done. I would have proven that the argument is invalid. But since I reached a contradiction on both line 1 and line 2, I have to go on to line 3 and see what happens. So here, B is true and A is false. Okay, the conditional claim is said to be true. I have a true antecedent and a true consequent, so that's fine. Here, the conditional claim is said to be true, but I have a true antecedent and a false consequent. So I've reached a contradiction there. Now, since each line necessarily leads to a contradiction, the argument is valid. We have not been able to sustain our assumption that it was invalid. If a contradiction had been avoided on some line, the argument would then be invalid because it would have been possible for the premises to be true and the conclusion false. Note that in this argument, it's not necessary to fill out all the truth values on any one line to be forced into a contradiction. If I had simply, look at line 2, if I had simply skipped over and started at the beginning and wrote out, okay, so A is false, not A is true, and B is false, I could have just stopped right there once I reached that contradiction. I only filled it out for the sake of demonstration. All right, I'm posting some exercises which will invite you to practice using the indirect method. Take a look at those. We will review them on the Tuesday after Thanksgiving break. As I indicated, on that day, we are also going to begin talking about proof theory. And so we're going to spend Tuesday and Thursday talking about proofs, and I will be posting some video lectures about proof theory, which will constitute your homework for the last week of class. I hope you have a good Thanksgiving break. Stay safe.